Hey guys, today we're going to take a look at theoretical probability. So theoretical probability is another measure of the likelihood of an event, but this time, unlike experimental probability, we're not going to perform any experiments. We're just going to base it on math. So theoretical probability measures possible outcomes. Possible. Okay? And the theoretical probability formula is just, and we usually write it as P with an X like that. I don't know why, don't ask me why. Okay, and the formula is just number of ways to succeed divided by the number of possibilities. Okay, so in order for theoretical probability to work, all outcomes must be equally likely. It will not work otherwise. And what I mean by this is each event has the exact same chance of occurring because the conditions are completely fair. Something like rolling a die or flipping a coin. Okay. The probability of an event is a value between 0 and 1, just like it was with experimental, or it could be between 0 and 100%. So those are percentages, okay? But it's the same thing. So, if we did our coin flipping experiment, we can use what we call a tree diagram here to just go through all the possible outcomes. So if we flip a coin 3 separate times, the first time we flip it, it can be either heads or tails. Second time, it can still either be heads or tails. And the third time, heads or tails, heads or tails, heads or tails, heads or tails. And let me walk you through what I mean by this, okay? If I flip the coin and the first one is heads, I go to here, okay? So now I'm here. And then if I flip tails, I go here, and now I'm here, and then I flip tails again, and that would put me right there. So it's just the branches split off from what just happened, okay? So the possible outcomes can be grouped into specific groups. I don't know what I was supposed to say there. It looks like it got cut off, but the idea is you can have right there, I have 3 heads, so I can have 3 heads. Okay, let's see, from here I have 2 heads, 1 tail. This one is also 2 heads, 1 tail, and this one is 2 heads, 1 tail. Okay, so in other words, there was one way that that could happen. There were 3 ways that that could happen. What's next? We could have 2 tails, 1 head for that one, and that one. Okay, so again, there were 3 for this one, and that is 4, 1 heads, 2 tails. And finally, we could just have tails, 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 okay? And there was only one way for that to happen, so that was 3 tails, okay? Okay, so we're going to talk about different events. Just ignore this, I don't really care about that. I'm going to do this a little differently. So we're going to talk about 3 possibilities. We're actually going to talk about 4 possibilities. I'm going to add an event C. So what we're going to say is, what's the probability of 3 heads? Okay, so the probability of event A, and what we would typically do is we'd write P of A like that, if it's probably, but it doesn't really matter. If you don't write it like that, I'm not going to care, to be honest. So there were 8 total possible ways of, or things that could happen, and one of them had 3 heads. Okay, so the number of ways of succeeding was just 1. There was only one way to get all 3 heads. Okay, so that was success. And you're going to divide it by the number of possible outcomes, which there were 8. So 8 outcomes. Okay, and that's all there is to it. So when we go to do probability event B, which we're going to say was 2 heads, 1 tail, okay, then it's going to be, again, we write P of B like that. And again, if you don't write it like that, I don't really care. Okay, but there were 3 ways to succeed. There were 8 possible outcomes. Okay, so 3/8 is the possibility. And finally, not finally. So we've got 1 heads, 2 tails. That was the same, so we'll call that probability event C. So that one was also 3 ways of succeeding and 8 possibilities. And then finally, this one's not here, but I'll write event D, which we'll say is 3 tails. Okay, well, probability of flipping 3 tails, there's 1 way to do it, and there's 8 possible outcomes. So there's a 1/8 chance that you are going to flip a tails 3 times in a row. Okay, so it's obviously much less likely that we would flip and get tails 3 times in a row as it was to flip and get 2 heads and 1 tails. Okay? All right. A standard deck of playing cards has 52 cards, 13 for each suit. If 1 card is drawn from the deck, we're going to find the probability that it is a heart. So first of all, we just say, well, how many of these things are hearts? Well, there's 13 hearts because there's 13 of each suit. So the 13 successes divided by the total number of outcomes, it's going to be 52. Okay, so 13 out of 52, which we could reduce then to 1 and 4, which you could kind of figure out because, I mean, a quarter of all the cards are fourths. If you wanted to, you could write this as 0.25 or 25%. Okay? All right. Let's do ace. So the probability of getting an ace, well, there's 4 aces in a deck, and there are 52 cards in a deck. So it's 4 and 52, which reduces to 1 and 13. Okay? I'm just going to leave that as a fraction. That's reduced fraction there. Okay? So that's it. All right, so let's see. A heart, a club, or a jack. So this is where things get more difficult. Okay? So the probability of a heart, well, there's 13 hearts, there's 13 clubs, but then there's 2 additional jacks, okay? Because there's 4 jacks total, but we've already counted the jack of hearts, we've already counted the jack of clubs, okay? So it's going to be the 13 hearts, plus we got 13 clubs, plus there's 2 additional jacks, and there's still 52 cards total. So we get 28 over 52. Okay, which, let's see, I think that reduces to 14, what is that? So 28 over 50 reduces to 7 over 13. There you go. Okay. And finally, a heart, a club, a spade, or a diamond. Well, I mean, you could probably figure this one out without doing the math, but I'm going to do it anyway. There's 13 hearts, there's 13 clubs, there's 13 spades, and there's 13 diamonds, all out of 52. You add that up, it's 52 over 52, which of course is 1 or 100%. And what that means is if you draw a card out of a deck, you're going to get a heart, a club, a spade, or a diamond. That's all of the cards. So there's a 100% chance that that's going to happen. Okay, assuming there's no jokers in this deck, which we have been assuming that all along because, you know, otherwise that'd be silly. So anyway, Jason rolls regular 6-sided die. So we're going to find the theoretical probability for each event. It wants us in a fraction and as a percent. I don't know, did the last one want percentages? It didn't say. Good, because I didn't do it. So what is the probability of rolling a 6? So first of all, rolling a 6. How many ways can I roll a 6? there's only one way to roll a 6. You have to get the 6. There are 6 possibilities on that die, so the probability is 1 in 6. Now, if you're going to convert this to a percentage, remember, just do top divided by bottom times 100. So 1 divided by 6 times 100, and that's going to give us 16.7%. Okay? Rolling a number greater than a 2, well, that means we're either rolling a 3, a 4, a 5, or a 6. So there's 4 numbers that meet that criteria, still at a 6. So we get 4 out of 6, which is the same as 2 over 3. So there's our reduced fraction, and that is 67% roughly. Okay. Rolling an 8. How many ways can you roll an 8? 0. So 0 out of 6 is just equal to 0, which is 0%. It is impossible to roll an 8 on a 6-sided die, so it's just 0%. Okay? Sometimes you can just use your brain on these. Okay, rolling an even number. There's 3 even numbers. There's a 2, a 4, and a 6. Still 6 possibilities. That reduces to 1 over 2. Again, you might have been able to figure that out because half of the numbers are even. Okay? And 1/2 written as a percentage is just 50%. Okay? And that's it. So until next time, go Sabres.